up, dudes and dudettes? Mr. Herr here on this cloudy Wednesday morning. Hopefully you enjoyed your evening last night. Hopefully you enjoyed the beautiful weather outside yesterday. It was picturesque. Yeah, and I don't know about you guys and gals, but we had some wicked thunderstorms here last night. It woke me up at like 1:45 in the morning. Shook the whole house, man. It was crazy. Or as the kids say, cray cray. Watch out. So hopefully, ladies and gentlemen, that's not too bad for you. And don't forget, make sure everybody's healthy, wealthy, and wise. Today we'll knock out confidence intervals when it comes to our samples. In a lot of ways, you're probably going to say this is easier than what we did yesterday when we were talking about finding sample deviation, sample mean. We're still going to use those concepts. It's just a different formula. So in the grand scheme of things, it's not too bad. And then I do have a 3-question PDF that I'd like you to knock out. Please upload a PDF with some work shown. I know some of us are doing our work on another piece of paper. I totally respect that. I also just want to make sure that, we're doing our part. Without further ado, let's do this thing. Sorry about the spring noise. 3, 2, 1. There you go. You survived. As always, this would be a good time to pause the video, grab a pencil and paper if you follow along. But at the same time, if you're a auditory learner and a visual and you can just watch and hear it and be good, that's awesome too. A Gallup poll conducted in May asked Americans how many books, either hardback or paperback, they read during the previous year. A survey consisted of 1,060 people with a sample mean of 7.2 and a standard deviation of 2.4. What is a 98% confidence interval for the mean number of books read? Okay, so we have our sample mean. For a lot of us, this is a little different. Sample mean looks like X bar. Have no fear there. When we see confidence interval, we know we're going to have a positive end and a negative end. Okay. And our formula looks like X bar plus or minus Z alpha over 2. Don't have a fear about that because our chart already tells us what that is. Times our sample deviation. If you're saying, what do you mean a sample deviation? It looks like our standard deviation divided by the square root of n. Okay. So looking here, and sorry for being a little, off to the side, our n value is 1,060. Our sample mean is 7.2. Our deviation is 2.4. And since we're looking at 98% confidence, we're going to grab our chart, which I'll be sure to upload another chart for you just in case you need it. Down here at the very, 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 very bottom, hopefully I can get this on the screen. Oh, my book doesn't want to play nice. There we go. Remember, we have levels of confidence. So 98% looking right there, we know our Z value is going to be 2.33. So that's pretty sweet as well. Okay. For lack of better words, we just substitute and go. 7.2 plus or minus 2.33, that was right off our chart, times 2.4 over the square root of 1,060. Now, you can type this in all at once. If we're going to be honest with each other, it's more accurate if you do type it in all at once, exactly the way it's written. But you and I both know that not all of us have calculators that can handle that. So it's one of those, hey, look, I trust you either way. So if your answers are a little different than my answers, no judging. But after we typed all this in, we have a lower half, which is where we take 7.2 minus 2.33 times 2.4 divided by the square root of 1,060. We have a lower confidence interval of 6.66. Ooh, devilish. And then an upper interval of 7.74. So that means we are 98% confidence that the true mean of books read lies between 6 and 6600ths and 7 and 7400ths. Okay. Once again, if you end up doing these problems and your numbers are slightly off because of rounding, I'm going to give you the benefit of the doubt because, you know, I know not everybody has a graphing calculator handy. Hey, let's knock out our next example. Same formula, same idea, and then we're going to have this thing wrapped. A poll conducted of 300 people, there's my n value, to determine the amount of time spent on Facebook in a month revealed a sample mean, that should say, of 171 minutes and a standard deviation of 56. What is the confidence interval if we need 95% confidence? Oh, my z value, you can look that up. That's going to give you a 1.96. That's just straight from our chart, okay? Then we just substitute and go one more time just so you don't think I'm pulling this out of thin air. My formula looks an awful lot like this. Our sample mean plus or minus our z value times our sample deviation. Well, in this case, we're looking at 171 plus or minus 1.96 times 56 divided by the square root of 300. Okay. Running the quick math, and please bear with me as I type. We get our lower half of our interval to look like 164 minutes and 66 hundredths of a minute, and our upper interval to look like 177 minutes and 34 hundredths of a minute. Once again, to give it perspective, that means our true mean, we are 95% confident that our true mean is in this interval. Okay, it's somewhere between 164 minutes and 177 minutes. Okay, you're going to have two problems like that on your PDF worksheet for today, and the first problem is actually a review z-score problem. So please don't panic when you say, "Oh, mister, it's not this formula." And if you're saying, "Oh, I need that review z-score formula," it looks an awful lot like this, with our x value minus our sample mean divided by our sample deviation. Okay? Hey, have a good day, ladies and gentlemen. Peace.